Now, as we move into topic 2 of chapter 3, we're going to be dealing with adding and subtracting these rational expressions. Now, the key is when the denominators are the same, then you just add your numerator and simplify. Later, we'll find when the denominators are different, we have to modify those fractions by making them equivalent fractions that have the same denominator. So, let's get started. They do start us off easy. So the technique then is to put all of your numerator over your common denominator, which in this case is x. So we have x plus 5 minus 1. And now we just group like terms, and we end up with x plus 4 over x. Now recall that x in the numerator here is a term, and 4 is a term. So you cannot cancel out common terms, only common factors. So this is as far as you can go. All right, now in example B, and we have lots of room, so you'll need lots of room too. Your common denominator is x squared minus 7x plus 6. So that's good so far. So we could put all of this on top, or since there's a plus there, we're just going to combine like terms. So when we add, this is 5x squared. This will be a positive x, and this will be a negative 6. Now you might say you're finished. Well, sort of. Now you have to look to see if this can be factored. And it can. So we need to factor the top and factor the bottom. This one's a little easy, so let's do it first. X 6, 1 has to add up to a negative 7. Now, in factoring the top, we know this has to be a 5x, and this is going to be an x. Now, we're looking for a difference of 1 here, so this negative 6 has to be here, I believe, and this will be a 1. So this will be a positive, and this will be a negative. And then if we FOIL it, it checks out. So again, you've done the first step. The denominator already is the same. So you've added like terms in the numerator, but you have to look to see if you can factor it. And now that it does factor, you see you have a common factor now of x minus 1 that you can cancel out. So your final answer then is this over this. All right, let's go on. Now this one is similar to what we've done. The denominator is the same. So it's m plus 3. Now a little technique that I like to use is when I see a negative there, which indicates subtraction, I'm going to make this a plus sign and move this negative sign up here. Alright, so we've changed that sign already, and now we group like terms. We have 2m squared. Now we have a positive 7m and a negative 4m gives me a positive 3m and then minus 9. Now here we're looking to see if we can factor something. Now again, may not recognize it right away, but you give it a try. And this would be 2m. Now, looking at that, you might say, well, a 9 and a 1 for a middle term, no. So let's try a 3 and a 3. Ah, that looks good. Because my outers now is 6, and this would be a 3, and the difference would be 3. Okay, so I need a positive, so this is positive, and this will be negative. And again, you FOIL it to check it, and it checks out well. So now we see a common factor that we can cancel out. So our end answer is just this, 2m minus 3. Now they do ask for restrictions of the domain, and this one's easy because there's only the one term. So we equal our denominator to 0, and we get m equals a negative 3. So that's our restriction. M cannot be a negative 3. Otherwise, it's all real numbers. In example 2, they're asking us to find the least common multiple of each pair of polynomials. So here we have an x to the third, and we have an 8x. So we can think of this as a denominator down here, where what would be our common denominator between these? Well, we would need the 8. And what power of x would we need? Well, we would need x to the third. So this would go into that, and this would go into that. So our common denominator then, or the least common multiple, is this. Now, in example B, we're looking to see what are the factors of this. So the first thing we have to do is factor each of these terms. Let me write them out here. So can you see this is a perfect square trinomial? And we want to separate our factors here. So normally we would write that as x plus 1, the quantity squared. And here, the difference of perfect squares would factor into its conjugates, x plus 1, x minus 1. Now again, we're thinking of a denominator, a common denominator between these, and the rule is, I'll say it slowly, what is the greatest number of times that any factor is used in any one factorization. So this is a factorization. This is a factorization. What's the greatest number of times that x plus 1 is used? Well, here it's used twice. Here it's used once. So the greatest number of times it's used is twice. So we include that as part of our future common denominator. And as they're referring to it here, the least common multiple. All right, well, what's the other factor? Well, x minus 1. What's the greatest number of times that x minus 1 is used in any one factorization? Well, here it's not used at all, and here it's used once. So we need one of those. And that is the procedure that we will be using here shortly to find out what our least common multiple, or what will be our lowest common denominator. So I would suggest you write this over on the other side. And since we're going to add these fractions, we need a common denominator. Well, we already figured out this one from the previous example. The lowest common denominator here is going to be 8x to the third. Now, what we need to do is modify this fraction so that this denominator becomes this. And we're going to multiply it by a 1 in the form of what? And the answer is 8 over 8. 8 over 8 is 1. We are allowed to multiply anything by 1 and not change its value. We do make it an equivalent fraction, though. So 8 times x to the third is 8x to the third. And 8 times 7 is 56. Okay. Now, in this denominator, we have 8x. What form of 1 are we going to multiply 8x by to make it 8x to the third? If you said x to the second, which is a form of 1, but now multiplying our denominator here makes it 8x to the third. Now our numerator becomes plus 4x squared. Now, you might think I'm finished. No, because I know I can take a 4 out of this term, and a 4 out of this term, and a 4 out of this term. So we're going to simplify this a little bit. And let's show you how we do it. We take a 4 out, so this becomes 14. A 4 out of there, this becomes x to the second. And this is all going to be over 4 times 2x to the third. So we're taking out a common 4 from both the numerator and denominator. These then cancel out, and this is our final answer. Now, on an exam, if it were on paper, and again, you're writing things out, if you ended up with this answer, I could give partial credit. Now, for these next examples, we need lots of room. So I'm going to clear this up and write the other one out. Now we know from the previous example what our denominator will be here. We said it was going to be x plus 1, x plus 1, and x minus 1. So we want to convert this denominator into this denominator. So it has these two parts. The part it's missing is this. So what I need to do there is multiply, and I'll put it up here, 2x times the part that I'm missing. In fact, I'm going to write it right over here. But I'll do it over here. And I'll do that multiplication and put it over here. Now, this term, or these terms, this numerator is missing what from here? Well, it has this and this. It's missing this one. So I have to multiply by that. And how do I do that? Well, I'm going to FOIL it. So I'll FOIL it and get back to you. So once again, I multiplied this by this that I have over here. So 2x times x is 2x squared. 2x times a negative 1 is a negative 2x. Okay, there's a plus there, so I don't have to worry about signs. I'm going to FOIL this. My outers give me a positive 5x to the third. My first, I should say. My outers give me a positive 5x squared. My inners, a negative 3x, and my last, a negative 2. So all over my common denominator. Now what do I do? Well, my common denominator stays the same, but now I combine like terms and put them in descending order. So 5x to the third, I have a 2x squared, and a 5x squared becomes a 7x squared. I have a negative 2x and a negative 3x, negative 5x minus 3. Now, that is my answer. Now, neat and orderly notes will allow you to get extra points if for some reason you made an error in there, and I want to do that. Okay, we need room, so we're now going to take a look at letter E. Well, letter E is subtraction. What I'm going to do, and I suggest you do also, put this in parentheses. Put the negative sign up there in front of the parentheses. Now in this step, we don't know what the new common denominators will be, so we start off by factoring what we have there, and we'll give you a chance to do so as well. So what will be our lowest common denominator? Well, for this, we'll look at what we've done before. We have the factor y minus 1, and notice there was a little typo that you had to change. How many times is y minus 1 used in any one factorization, or the greatest number of times? Well, it's used once, so we need one of those. Now how about y minus 4? Well, here it's used once, here it's used once. So we need one of those. Now the other factor we haven't looked at yet is y plus 1. What's the greatest number of times that's used in any one factorization? Well, it's used once. So our lowest common denominator here then will be y minus 1, y minus 4, and y plus 1. Now we then go up into what we have here in the numerator, and we want to make this fraction equivalent so that it has this denominator. So we look and see which factor is this missing, and we see it's missing the y plus 1. So we put it up there, y plus 1. And as we look at this denominator, which factor is this missing to become this? And we see it's a y minus 1. Now remember, there's a negative sign there. Here we go. So, what do we do now? Well, now we're going to FOIL these and FOIL these, keeping in mind there's a negative sign out in front of this. So we'll do this over here, and we'll let you FOIL it too. Okay, checking the FOIL. This is actually squaring that binomial to get a perfect square trinomial here. And then when we do this, we get a positive 2y squared right there. Our outers, a negative 2y. Our inners, a negative 5y, which gives us a negative 7y. And then negative 5 times negative 1 gives us a positive 5. Now we have this negative sign in front. So this line will now become y squared plus 2y plus 1. Now, to remove the parentheses with a negative sign in front, we just change all these signs. So this will become a negative 2y squared, a positive 7y, and a negative 5. Now we're going to group like terms. So we get a negative y squared, a 2y and a 7y is a positive 9y, a positive 1 and a negative 5, negative 4, all over our common denominator. Okay? So again, lots of stuff going on, needing to check your work often and following the protocol. Now notice this one example can take 5-8 minutes to do. As you check it, you want to get the right answer. But lots of stuff going on here. In example F, notice our denominators are very similar already, except this one's plus and this one's a negative. Do you remember we said we could put this negative sign up in the numerator, and then this will just become a positive? Ah, what an easy trick in a sense to change our denominators, which is now 7t, and 4 minus 1 would give us 3 over 7t. All right, so that's a little trick that we could use every once in a while. Remember, we can change, or we could factor out a -1 there and do that. But this is the easiest way to do it. All right, so let's take a look at this one. So again, our denominator looks interesting here in that this is 5x minus 2y. This is a positive 2y minus 5x. Okay, so what can we do? Let's just work with this side for a moment. If I wanted this denominator to look like this, here I could take out a -1 and just reverse the signs. So this would be 5x minus 2y. So just by taking out a -1, and we said we could put this negative sign up here and make that a positive. Now, I don't know if you can see this, but this now is this. And do you see we have a negative divided by a negative? What will that become? A positive. So, we showed you how it's done by taking a negative out of here. It becomes this. So our lowest common denominator, I'm going to erase this one now, is 5x minus 2y. The 3x stays there. And now when I move the negative sign up there, and then I had the negative down below, this became a plus. So this now is 4y plus 5. And that's the answer to letter G. So these are just maybe a few shortcuts as we look at this type of example. Now in letter H, and I'll clear this up here, we have a subtraction and an addition. And we have 3 terms. So what will our lowest common denominator be here? Can you see that this is the difference of 2 squares and these are the conjugates? So our lowest common denominator is actually this. So this 4 here is already over this. Now we said we're going to make this positive and put the negative there. We don't have to use parentheses since it's only one term. Now, what do we need to modify this numerator with this denominator to make it this? Well, we have to modify that by multiplying it by the one it's missing, which is this one. So this is going to be x minus 3 there. Now we have a plus 2, and what part of the denominator is this missing? Well, it's missing the x plus 3. So we put that there. So our lowest common denominator is this. These are the conjugates of that. So we just multiply the part that's missing by the numerator, and this is what we get. So let me give you a moment now to do this as I do it. And be careful of the signs. And now we group like terms. A negative x squared. Then we have a positive 5x, these two, and a positive 10, all over our common denominator. Now, theoretically, you could have foiled this, but MATLAB tends to want you to leave it in its factored form. Okay, well, again, lots of technique here where you have to do things carefully, orderly, neatly, and double check your work.